Hey guys, Mr. Backerberg here. In this video, we're going to look at proving identities. Now, as we're looking at proving identities, what's going to happen is we're going to be told that two expressions are equal to each other. But it's our goal to go through and prove it by taking one side of our expression and transforming it into the other side of our expression. And we're going to do this by making some algebraic manipulations or replacing things using what we know about our trig identities. Now, sometimes this can be a pretty difficult task, especially as we're just getting started with this stuff. So I've provided you with some helpful hints to try to guide us along the way. So helpful hint number one says that we're going to work with one side of the equation at a time. And it's often better for us to work with the more complicated side first and try to work towards getting the less complicated expression by doing our algebraic manipulations and making some substitutions with our trig identities. Number two says that we're going to look for some opportunities to factor or add fractions, square binomials, or get a monomial denominator if we're dealing with fractions. Number three, we're also going to look for some opportunities to replace things using our fundamental identities. We want to keep in mind the functions that we currently have in our expression, and we also want to think about the functions that are in our final expression so that we can try to make appropriate substitutions. Now, one thing, if we kind of get stuck, we can try converting everything into sines and cosines and see if that can find us a path in the right direction. Now, as we're working, if we do get stuck on one side, we can try switching over to the other side and find a common middle point between the two sides. And lastly, we always have to try something. Even making an attempt that leads to a dead end is better than trying nothing at all. So as we're taking a look at this first example, we want to prove that the tangent of x plus the cotangent of x is equal to the secant of x times the cosecant of x. Now, we said that we were going to look to start on the more complicated side, and as we're looking at this equation, the left side is actually a little bit more complicated because it's got two separate terms, whereas the right-hand side only has one term. Now remember, we're only allowed to work on one side of the equation at a time, and we can't move something from one side over to the other side, so I like to put a vertical line through my equal sign to remind myself that I can only work on one side at a time. So we're starting on the left-hand side, and the first thing I want to do is I actually want to take these tangents and cotangents and convert them into sines and cosines. So we've got some quotient identities that we can use. The quotient identity for the tangent says that the tangent of x is equal to the sine of x over the cosine of x. So I can replace this tangent of x with the sine of x over the cosine of x, and I can replace this cotangent of x with the cosine of x over the sine of x. Now, what I notice is that we're adding two fractions together, but right now those fractions have different denominators, and I want to get a common denominator. So with this first fraction, I'm going to multiply top and bottom by sine of x, and with this second fraction, I'm going to multiply top and bottom by cosine of x. Now, when we do this, our sine of x times sine of x is going to be the sine squared of x over this cosine of x times the sine of x, plus, now if we take cosine times cosine, that's going to be cosine squared of x. Now my goal is to get a common denominator, so I'm going to write these denominators the same. So I'm going to switch this around and make it say cosine of x times sine of x. But now the whole goal of getting common denominators would be so that we can put our fractions together. So I can really take these two separate fractions and combine them to say the sine squared of x plus the cosine squared of x all over cosine of x times the sine of x. Now on top, we've actually got one of our Pythagorean identities happening. And one of our Pythagorean identities says sine squared plus cosine squared is equal to 1. So I can replace that entire numerator with 1 over the cosine of x times the sine of x. Now this next step isn't 100% necessary, but what we can actually do with this is because there's multiplication happening on the bottom, I can actually split this big fraction up into two smaller fractions. So I would take 1 over the cosine of x times 1 over the sine of x. But I think doing that makes seeing the reciprocal identities a little bit easier. 1 over the cosine of x, using one of our reciprocal identities, is the secant of x. And 1 over the sine of x, using a different quotient identity, is the cosecant of x. Now this matches up with what we've got on the right-hand side. So we can say that this proof is complete. We have shown that the tangent of x plus the cotangent of x is in fact equal to the secant of x times the cosecant of x by taking all of these different steps. Now, as we're taking a look at this second example, we've got 1 over the secant of x minus 1 plus 1 over the secant of x plus 1 equals 2 cotangent of x times the cosecant of x. Now, we're going to start on the left-hand side because that's more complicated. And what I see happening is that we're trying to add two fractions together. But in order to do that, we need common denominators. So what I'm going to do is multiply top and bottom of each fraction by the opposite fraction's denominator. So over here on the left-hand side, we're going to multiply top and bottom by the secant of x plus 1. And with our fraction on the right-hand side, we're going to multiply top and bottom by the secant of x minus 1. Now the tops are going to be easy because we're just multiplying by 1. So the top of this fraction on the left-hand side is just going to be the secant of x plus 1. The top of the fraction on the right-hand side is going to be the secant of x minus 1. Now in those denominators, we're going to do a little bit of FOILing. If I take the secant of x times the secant of x, that's going to be the secant squared of x. Then secant times minus 1 is going to give me a minus secant of x. 1 times secant is going to give me plus secant of x. And 1 times negative 1 is going to give me negative 1. Now what we should notice is that with this minus secant of x and this plus secant of x, those are going to cancel each other out. So this fraction on the left-hand side is going to be the secant of x plus 1 over secant squared of x minus 1. Now this fraction on the right-hand side, we have to do the same FOILing on the bottom, but we already know that that's going to simplify down to the secant squared of x minus 1. Now that we've got our common denominators, we're going to go ahead and put our fractions together. So we've got the secant of x plus 1 plus the secant of x minus 1 all over that common denominator of the secant squared of x minus 1. Now on top, this plus 1 and this minus 1 are going to cancel each other out. And we're going to be able to combine those secants on top. If I take a secant of x plus another secant of x, then that's 2 secant of x over secant squared of x minus 1. Now in the denominator, I see one of our Pythagorean identities. So we're going to be able to replace that secant squared of x minus 1 with the tangent squared of x. Now what I'm going to do in here is I'm actually going to separate some things. So I'm going to take this 2 secant of x off of the top of my fraction, and this is going to turn into 1 over the tangent squared of x. Now I know 1 over the tangent of x is the cotangent of x, but since this is tangent squared, when I do the reciprocal of that, then that's going to become the cotangent squared of x. Now I'm going to go back up and look at where we're trying to go. I'm trying to get a cotangent and a cosecant in there. And right now I've got a secant and a cotangent squared. Now it might not be very obvious what to do next, so one of our strategies says that we can turn things into sines and cosines. So this is going to be 2. Now for the secant, I'm going to turn that into 1 over the cosine of x. And this cotangent squared, we've got a quotient identity that says cotangent is cosine over sine. But since this is cotangent squared, I can make it cosine squared of x over sine squared of x. Now what's going to happen is this cosine on bottom is going to cancel out with one of those cosines on top. So now we've got ourselves 2 times a cosine of x over a sine squared of x. Now I'm actually going to split this up. I want to have a cotangent in my answer, so I need to have a cosine over the sine. But what we've actually got is 2 sines happening on the bottom. So I'm going to make it 2 times cosine of x, and I'm going to grab one of those sine of x's, but then I'm going to make this other one 1 over the sine of x. But then I can use a quotient identity with this cosine of x over the sine of x. So that's going to turn into the cotangent of x. And I can use a reciprocal identity with this 1 over the sine to make that the cosecant of x. And that matches up with what we wanted. So we have proven this identity. In this example, we've got the cosine of t over 1 minus the sine of t equals 1 plus the sine of t over the cosine of t. I'm going to start on the right-hand side this time. Now, it's maybe not super obvious where to start on this one, but what I notice is that the left-hand side of my fraction has a cosine of t on top, but as I look at the right-hand side, it doesn't. So I could think about multiplying a cosine of t on the top of my fraction, but whatever I do to the top, I also have to do to the bottom. So this is going to turn into 1 plus the sine of t times the cosine of t all over, if we take cosine times cosine, that's going to be cosine squared of t. Now with this cosine squared, we can actually use a Pythagorean identity. Cosine squared can be replaced with 1 minus sine squared of t. So we have 1 plus the sine of t times the cosine of t over that 1 minus sine squared. Now actually on bottom we've got a difference of squares that we're going to be able to factor out. So it's going to be 1 plus the sine of t times the cosine of t. Now if I split this up, a difference of squares, that's going to factor into 1 plus the sine of t and 1 minus the sine of t. Now what I notice is that I've got a 1 plus the sine of t on top and on bottom. So those are going to cancel each other out, leaving me with just the cosine of t on the top of my fraction and 1 minus the sine of t on the bottom of my fraction, which is exactly what we wanted. So we have proven this identity. In this example, we've got the cotangent squared of u over 1 plus cosecant of u equals the cotangent of u times the secant of u minus the tangent of u. Now, both sides seem pretty complicated because they've got a lot of stuff happening, but the left-hand side, since it has that fraction in there, is probably the more complicated side. So I'm going to start on the left-hand side. And what I'm actually going to do is start with the numerator because I can use one of my Pythagorean identities in there. I can replace that cotangent squared of u with the cosecant squared of u minus 1, and that's over our 1 plus the cosecant of u. Now we've got a difference of squares on top, so we can actually factor that out. So that's going to become the cosecant of u plus 1 and the cosecant of u minus 1, all over that 1 plus the cosecant of u. Now I know it's out of order, but this cosecant of u plus 1 is the same as 1 plus the cosecant of u. Addition is commutative, so the order doesn't really matter. So I can cancel that out. And that gets me to the cosecant of u minus 1. Now as we look at the other side, it's probably pretty difficult for us to see what to do. But we have to remember that we are allowed to switch sides if we get stuck. So that's actually what I'm going to do. I'm going to switch over to the right-hand side and see if I can get this right-hand side to maybe meet up with what we've got on the left-hand side. And what I'm going to start with doing is turning things into sines and cosines. So the cotangent of u is cosine of u over the sine of u. And if I use a reciprocal identity with that secant, that's going to be 1 over the cosine of u minus, now tangent is the sine of u over the cosine of u. Now I've actually got a little bit of distributive property that I can do. So I'm going to take this cosine of u over the sine of u and distribute it to both of my terms. So then I'm going to have the cosine of u over the sine of u times 1 over the cosine of u minus the cosine of u over the sine of u times the sine of u over cosine of u. Now as I look at my first set of fractions with that multiplication, we've got a cosine on top and bottom, so those are going to cancel each other out, leaving me with 1 over the sine of u. Now in my second set of fractions, the cosine on top and bottom are going to cancel each other out, and the sine on top and bottom are going to cancel each other out. Now because everything is canceling out, we're leaving ourselves with a minus 1. Now that 1 over the sine of u, I can use a reciprocal identity in there to turn that into the cosecant of u, and then we've got this minus 1. And if we notice, we've gotten the same thing on both the left-hand side and the right-hand side. We've got that cosecant of u minus 1. So because we were able to find a common middle point between our two sides, we have proven that this identity is true. That's going to be it for this video. Thanks for watching.